All right. So I'm going to start with the slide number 10, which is a public interface, right? And then it show here the INT size. INT size is basically we are technically we are creating a stack, right? So let's draw a stack. Okay. Let's draw a stack. Okay. So INT size. So inside here, basically, how many stack that we want to create? Let's say we're gonna create like five stack. So there's a one, two, three, and four, which is one, two, three, four, and five. Okay, so let's say we're creating a five stack, right? So int size in the bracket five, so we get this stack, this sort of a shape, right? This is basically a stack, alright, okay. So now let's move on with the next slide, which is slide number 11. Here we can see is that it's mentioned a boolean is empty. Boolean is empty is some sort of like a class which is telling us to check whether we have a value inside the stack that we just create just now. uh, okay, we just want to double check, right? We just want to check, is there any value here? If there's a value, we show the output. So that basically the explanation on boolean is empty. Okay, now we're moving on the void push, which is on the next part on this slide, which is mentioned here, void push e element. Right. So void push, the actual meaning of push, I mean in other word, push is basically we are inserting the value, right? Basically push, we are inserting the value, right? When we inserting the value, you're gonna fill up from the bottom to the top. Okay, that's basically it. So in the bracket, it's showing here is the e element. Okay, e element is basically the value that we want. For example, let's say we want to insert the value of 1. Sorry, let's say try the value 2. So what we're going to use is void push in the bracket 2. So once we did that, okay, then it's going to insert the value of 2 inside here. Right. Let's say you want to fill up all the stack. You can actually insert the value by using the same thing again, but just now we use the void push 2 in the bracket, and then we let's say we want insert a value of 5. Okay, then we repeat again, void push 5 in the bracket, so we get here the value of 5, right? And yeah, let's we're gonna repeat. Okay, let's say we put the values is 1, 2, and then 7. Okay, right. Oh, I don't want to put the value. Say it's 3 here, and then there's a 7 output here. Okay, so we got here's our stack. Okay, 2, 5, 1, 3, 7. So this is the value. We can actually use the system out dot println stack, then we show the value already inside here. All right, move on to the next slide. So the first thing is showing here is epop. Okay, imagine like a balloon. Okay, imagine you have a lot of balloon. If you pop it, if you pop the balloon is going to destroy, right? It's technically it's destroy. So it same goes to the same here. So when we type epop, right, it's gonna remove the value of 7. Okay, but you have to be careful. Epop is not technically like removing the value from the top. It's actually removing the utmost recent inserted value. That's the meaning of epoch. Okay, so E is element, which is the object of E. We're gonna pop we're gonna delete the data, and so yeah, so that is so that's basically epoch. So epoch is basically um removing the most utmost recent inserted value. So this is basically okay, this is basically pop, right? And the green one is basically push is inserting the value, right? Moving on the peak. Okay, peak. Peak, we have all the data inside the stack, right? So e peak is technically we are taking the most highest value or taking the top most value in the stack. So in our example here, we have 2, 5, 1, 3, 7. Okay, let's say the value of 7 is putting right in the middle in 1. Okay, okay, just imagine that we're swapping the value of 7 into 1. Okay, so when we use the EP, it doesn't matter where the value of 7 is. Okay, it doesn't matter, but the EP is technically showing the highest value of in the stack. So that's basically EP. Okay, so let's let me show again. EP, if we pick let me see here. Pick is technically taking the taking wait, we can't really see on the yellow. Let's say we're gonna use black, which is taking topmost value, right? That's basically pick. So let's wrap around again. I want to select number 10. In size, which is basically creating a stack size in the bracket. How many stack do we want? Then again, boolean is empty just to check is there any value inside the stack. And then next with a void push, which is be inserting the value inside the stack, and pop removing the stack. Sorry, removing the value inside the stack. Um, then pick, which is taking the topmost value in the stack. Okay.
Assalamualaikum warahmatullahi wabarakatuh. My name is Fadhlan. So I'm going to continue what my friend already explained in previous video. And so now we're going to focus on the practical point of view of the method in ArrayPureStack class. So we're going to use Java compiler, and we're going to refer on the slide which can be found in the VLE. Alright, so before that, we have two different kind of files that we will be using. The first one is purestack.java, which contains the interface, and then we have the main file which contains the program, the main program called ArrayPureStack.java. So by referring to the slide, the class ArrayPureStack will be implementing the PureStack interface as shown in this line or here in line number 2. Public class ArrayPureStack will implement PureStack. And then we have two different kind of attributes. The first one is private element stack, which is the container for the data. And then we have private integer size, which indicates the next open slot in the array. Now in this slide, it's only explained about the rule and law of array indexing, which most of you guys already understand how index works in array. So we're going to skip this part. We're going to continue to the constructors. We have two different constructors in ArrayPureStack which can be used to create empty stack. So the first one is default capacity, and the next one, the second one, is initial capacity. So what's the difference between these two? The default capacity is where the user stated the size of an array beforehand. As shown in line 4, the default capacity is 10. That means the program will be using 10 as the main size of the array. There will be no 11th element or 12th element. The size will be 10 and it will stay like that. It will not state as default capacity if the user stated the initial capacity. So what is the initial capacity? The initial capacity can be stated here in the main class. Here we have array pure stack integer name s equals to new array pure stack integer, and then we have a parameter which is empty. If we leave it like this, the whole program will use the default capacity, which is 10, as the main size of the array. And if let's say I want to increase it to 20, and then I run the program, the new size will be 20. It will override the default capacity and use the new capacity instead. So that's the difference between default capacity and initial capacity. Good. So now we're going to continue with the method that we have in ArrayPureStack class. So now we're going to focus on isEmpty method, push method, pick method, and pop method. And before that, all these methods were written on top. Here we have isEmpty, pick, pop, and push. So each method will produce different output. So we're going to have 4 different outputs. So we're going to execute the code and see what's going to happen. Alright, so we have 4 different line of output. So the first one just showed empty array. Since the first method is empty, it's going to check whether the array is empty or not. Since the array is empty, it will shows an output like this. And then we're going to continue with push method. Here we can see we have 6 index which started from 0 until 5, because I is equal to 0 and I is lower than 6, which is the outmost value will be 5 and the total index will be 6. So that's the function of push method. It will push the element inside the array as shown in the second line. And then we have pick method. Pick method, it will show the array until the outmost index, the outmost element, which is 5. So that is the purpose of pick method. And the last line is pop. So since stack is using LIFO, last in first out, so the first index will be the last element that will be expelled from the stack. So that's why on the last line, based on the codes in line 110, we are reducing 5 elements which will started from element 5 until 1. 5 index, 5 elements, and the last element will be 0, which stayed in the array. So that's it for ArrayPureStack classes. So thank you very much.